The Age of Climate Extremes, How the Weather Turned Against US. Part 1. When the weather went weird. Not long ago, extreme weather sounded rare. A once-in-a-century flood. A freak heatwave. A storm so strange it would be remembered for generations. Today, it feels like the extremes never stop. One week, a city is roasting under record heat. The next, another region vanishes underwater. Hillsides collapse in landslides. Wildfires turn forests into glowing scars that can be seen from space. Every year, the headlines repeat. Highest temperature ever recorded. Worst flood in living memory. Strongest storm to hit this region. It raises a simple, unsettling question. Has the weather lost its mind? Or have we pushed the planet into a new age, an age of climate extremes? Before we step into the science and the stories, make sure to like, share, and subscribe to Uncovering Facts, where we go beyond the headlines to uncover what's really happening to our world. Now, let's follow the storm. Number 1. Weather versus climate, the loaded dice. First, we need to clear up a big misunderstanding. People often say, if climate change is real, why is it snowing? Why did we have a cold day last week? That confusion comes from mixing up weather and climate. Weather is what you feel today. The temperature outside. The rain on your window. The wind that knocks over a tree. Climate is the pattern of that weather over decades. It's the average of thousands of days, across many years. One storm does not define a climate. But thousands of storms, stronger, stranger, and more frequent, do. Imagine a dice. In a stable climate, that dice has equal chances. Cool days, warm days, rainy days, dry days. Now, add greenhouse gases, trap more heat in the atmosphere, and the dice begins to change shape. The extreme heat side gets bigger. The record rainfall side gets heavier. You can still roll a cool day, but the odds have shifted. Climate change is not about one storm. It's about loading the dice so that extreme events become far more likely. Number 2. A planet with a fever. Why is the dice changing? Because Earth has a fever. The physics is simple. The sun sends energy to Earth. Some of that energy is reflected back to space by clouds, ice, and bright surfaces. The rest is absorbed by land and oceans, warming the planet. Earth then radiates heat back into space, mostly as invisible infrared radiation. Greenhouse gases, like carbon dioxide, methane, and nitrous oxide, act like a thin blanket. They let sunlight in but slow down the escape of heat. Without them, Earth would be a frozen rock. But humans added too much of this blanket. Burning coal, oil, and gas. Cutting down forests. Intensive agriculture. In just a couple of centuries, a blink in geological time, we have raised atmospheric carbon dioxide to levels not seen for millions of years. Since the late 1800s, the average temperature of the planet has risen by about 1 degree Celsius. 1 degree might not sound like much. But imagine giving every square meter of Earth's surface just a little extra heat. Oceans soak it up. Ice melts. Air holds more water. The result is not just a bit warmer, it is a climate system with more energy, ready to express itself through extreme events. A planet with a fever does not simply feel hot. It behaves wildly. Number 3. Heatwaves, the invisible disasters. When people think of disasters, they picture raging rivers or roaring winds. But the deadliest extremes are often the quietest, heatwaves. In many countries, the hottest days of the year are getting hotter, longer, and more frequent. What used to be a once-in-50 years heat event now appears every decade, sometimes every few years. Heat waves don't crash through your roof. They creep into your body. As temperatures soar, the heart works harder, blood thickens, dehydration sets in. Older people, children, and those who work outside, farmers, builders, street vendors, suffer first. If nights stay hot, the body never gets a chance to recover. Hospitals fill quietly. Death statistics spike days later. Many of those deaths never make headlines. Cities become urban ovens. Concrete and asphalt absorb heat during the day and radiate it back at night, creating urban heat islands several degrees hotter than surrounding areas. In informal settlements and slums, where people live in metal-roofed shacks, indoor temperatures can reach unbearable levels. Heat waves also damage infrastructure. Roads soften and buckle, rails warp, power grids strain under the demand for cooling. And every degree of extra heat sets the stage for other extremes. The warmer the air, the more energy it stores, and the more moisture it can hold. Which brings us to the next act of this drama, when the sky finally lets go. Number 4, sky bursts, floods in a flash. Warm air is like a sponge. The warmer it gets, the more water vapor it can hold. But a sponge can't hold water forever. Squeeze it, and everything comes pouring out at once. In many parts of the world, rain is arriving in shorter, more intense bursts. Instead of gentle, soaking rains, we see sudden downpours, cloudbursts that drop a month's worth of rain in a day, or even an hour. Cities, built with concrete, poor drainage and narrow channels, cannot cope. Water races across surfaces, swallowing roads, homes and cars. Sewage systems overflow. Polluted water spreads disease. In rural, hilly areas, soil loosens, rocks detach, and slopes slide, triggering landslides that bury homes and roads under mud and debris. These floods don't just destroy property. They also erase years of progress. Roads, schools, clinics, and farms built with limited resources vanish overnight. Villagers who once feared droughts now fear both droughts and floods, sometimes in the same year. Climate change is reshaping not just how much rain falls, but how and when it falls. Number 5. Droughts, the waiting disaster. At the opposite extreme of flood lies drought, the disaster that arrives slowly, silently, and stays too long. Drought is not just less rain, it is a combination of factors: lower rainfall, higher temperatures, drier soils, faster evaporation. Even if rainfall stays similar, hotter air dries the land faster, turning normal dry spells into severe droughts. Crops fail. Pastures turn brown. Rivers shrink into trickles. Farmers watch seeds refuse to sprout. Livestock grow thin and die. Food prices rise, hitting the poorest hardest. In some regions, droughts push people to migrate not because they want to leave, but because staying means hunger. Drought also feeds the next type of extreme. When landscapes dry out for months, all it takes is a single spark. Number 6. Fire seasons that never end. In a warming world, wildfires are changing in 3 ways. They are burning more land, becoming more intense, and in some places, they are burning for longer seasons, sometimes almost year-round. Dry vegetation acts like fuel. High temperatures and low humidity create a perfect environment for flames. Strong winds then turn a simple fire into a moving wall of heat. Fires leap across roads. They jump rivers. They create their own small storm clouds that produce lightning, starting more fires. Beyond the flames, smoke spreads over thousands of kilometers. People who never see the fire itself inhale fine particles that penetrate deep into the lungs and bloodstream. After the fire, when heavy rains eventually come, burned soil is less able to absorb water. This increases the risk of flash floods and mudslides, a double hit after destruction by fire. Forest regions that once stored massive amounts of carbon begin to release it back into the atmosphere, reinforcing the warming that made them burn in the first place. The boundary between fire season and rest of the year is fading. For some places, it is simply before the fire and after. Part 2. Storms on steroids. Heat waves, floods, droughts, and fires are only part of the picture. There is another, more dramatic kind of extreme: storms that seem to have eaten lightning for breakfast. Number 7. Cyclones, hurricanes and typhoons. Around warm oceans, powerful rotating storms form, called cyclones, hurricanes or typhoons depending on the region. These storms feed on warm water. The warmer the sea surface, the more fuel they have. As the climate warms, more regions reach temperatures that can sustain very strong storms. And storms that already exist can intensify more rapidly. We are seeing more cases of rapid intensification where a storm jumps in strength from manageable to extremely dangerous in just a day or two. That gives coastal communities less time to prepare or evacuate. Higher sea levels then amplify the damage. A storm surge that might once have barely reached a seawall now overtops it, flooding homes and fields. Even after a cyclone's winds weaken, its rainfall can remain heavy, causing inland flooding hundreds of kilometers from the coast. Storms have always been part of Earth's climate system. But in the age of climate extremes, they are like familiar beasts, with unfamiliar strength. Number 8. The jet stream, when the sky's river wobbles. High above us, powerful winds circle the planet in narrow bands called jet streams. They form where cold polar air meets warmer mid-latitude air. These jet streams guide weather systems, steering storms and controlling where heat and cold linger. As the Arctic warms faster than the rest of the planet, the temperature contrast that drives the jet stream weakens. Some scientists suggest this can cause the jet stream to wobble and form large loops. When that happens, weather systems can get stuck in place. Heat waves sit over one region for weeks. Rain stalls over another, causing prolonged flooding. Cold polar air plunges deep into lower latitudes, bringing snowstorms to places that aren't used to them. Instead of weather patterns moving smoothly west to east, we get block patterns, where extreme conditions refuse to leave. This is why some places experience not just a hot day, but weeks of relentless heat. Not just a rainy afternoon, but a month of rain. The basic rule of the age of extremes is simple: when the atmosphere changes, it doesn't just change what happens, it changes how long it happens. Part 3. The human cost. Behind every graph of rising temperatures, behind every map with red and blue zones, there are people. Number 9. Cities on the front line. Cities were not designed for this level of heat, rain and chaos. Many grew along rivers and coasts, perfect for trade, but now highly exposed to floods and storm surges. Poor planning, informal settlements and weak infrastructure make things worse. In many developing cities, homes sit on floodplains, drainage channels are clogged, and electricity systems are fragile. A single extreme event can bring an entire city to a standstill. No power, no clean water, no safe roads, no way to reach help. In richer cities, the problems are different, but still serious. Aging infrastructure strains under new extremes. Heat waves kill residents in apartments without air conditioning. Insurance systems struggle to cope with mounting losses. As extremes mount, some cities are forced to ask hard questions: where to build, what to protect, and in some cases, what to abandon. Number 10. Food, water and conflict. Climate extremes are not just weather problems. They become food problems, water problems, and sometimes security problems. Droughts shrink harvests. Floods destroy stored grain. Storms wipe out fisheries and farmland. When food becomes scarce, prices rise. Poor families spend a larger share of their income just trying to eat. Water shortages strain relations between cities and villages, between upstream and downstream communities, and even between countries that share rivers. Climate change doesn't create conflict out of nowhere, but it acts as a threat multiplier, exacerbating existing tensions. A failed harvest won't automatically cause war, but in a region already stressed by inequality and political tension, it can be the spark that lights a fuse. The age of climate extremes is not just about storms in the sky. It is about storms in societies. Part 4. Can we control the weather? Myths and experiments. Whenever weather behaves strangely, rumors spread. Some blame secret government projects. Others point to cloud seeding, HAARP, or mysterious weather weapons. It is true that humans are experimenting with ways to influence the weather, mostly to increase rain in dry areas or reduce hailstorms. The most common method is cloud seeding, spraying tiny particles like silver iodide into certain clouds to encourage raindrop formation. These methods can sometimes nudge local weather, but their power is limited and unpredictable. What we are really doing, on a massive scale, is something far simpler and more obvious. We are changing the composition of the atmosphere itself. Billions of tons of greenhouse gases, released by everyday activities, driving, heating, farming, industry, have far more influence on global weather patterns than any secret project. In a sense, we have already become accidental weather engineers. We just didn't read the manual. Number 11. Fighting back, mitigation and adaptation. So, what can be done in the age of climate extremes? There are two main strategies: mitigation, reducing the causes of climate change; adaptation, reducing the damage from its effects. Mitigation includes transitioning from fossil fuels to cleaner energy sources, improving energy efficiency, protecting and restoring forests and wetlands, changing agricultural practices to emit less methane and nitrous oxide. Adaptation includes building better drainage and flood defenses, strengthening buildings against storms and heat, developing early warning systems, redesigning cities with more green spaces and shade, supporting farmers to grow more resilient crops. No single country can solve this problem alone. Greenhouse gases mix globally, but every ton avoided or removed slows the loading of the dice. The difference between a world that warms by 1.5 degrees Celsius, 2 degrees Celsius, or 3 degrees Celsius is not just a number on a chart. It is the difference between manageable extremes and overwhelming disasters. Part 5. Living in the age of extremes. We are the first generation to clearly see what is happening to our climate, and perhaps the last generation with a real chance to change where this story goes. Our grandparents lived in a world where extreme weather was truly rare. Our grandchildren could live in a world where extremes are the norm unless we act. This doesn't mean living in constant fear. It means living with awareness and responsibility. Paying attention to local weather trends. Listening to science rather than rumor. Pressuring leaders to plan for the future, not just the next election. Supporting solutions, from clean energy to better land management that reduce risk instead of increasing it. The age of climate extremes is not a prophecy we are forced to accept. It is a warning, and a test. Closing. Before the storm passes. One day, centuries from now, historians, if there are any, may look back at this period as a turning point. They may say, this was the moment when humanity realized that the climate was not just a background setting, but a living system that could be harmed and healed. Or they may say, this was the moment when warnings were ignored, and the dice of disaster was loaded beyond repair. Which story gets told depends on what we do now. If this journey through the age of climate extremes has made you see the weather differently, don't let it end here. Like this video to push it higher in the algorithm. Share it with someone who thinks it's just bad weather. Subscribe to Uncovering Facts for more deep dives into the hidden forces shaping our planet and our future. And tell us in the comments, what extreme weather have you experienced in recent years? A brutal heat wave, a A strange storm. A flood that never used to happen. Your story is part of the global story. And as long as we keep uncovering facts and acting on them, there is still hope in this age of extremes.